Now, sometimes when you're solving a system of equations and trying to use elimination to solve it, you see something like this where you don't have any terms that will add to 0. Negative 3x plus x do not add to 0. Negative y and negative y does not add to 0. So the solution, the thing we need to do in this case is multiply one of these equations so that multiply both sides of one of these equations by the same number so that we do get an opposite term. So here's what I'm going to do. I'm going to take the first equation, and I'm not going to multiply it by anything. I'm just going to rewrite it. So the first equation will be negative 3x minus y equals 2. That doesn't change. But the second equation, I'm going to multiply both sides of the equation by 3. And where does that get me? Well, that gets me 3x minus 3y equals 3 times 0, which is 0. And so this is good news because look what I can do. Now I can add negative 3x and positive 3x, and I can get 0x, negative 4y plus negative 3y, or negative y plus negative 3y is negative 4y. 2 plus 0 is 2, and that eliminates x, and I'm just solving now for one variable. So that's good news. That's the way we want to do this. So let's look at another example of this. Here's another situation where we don't have any terms that will cancel out when we add. But if I multiply that first equation by 2, then I will have terms that will cancel out. Let me show you what I mean. 2 times x would be 2x. 2 times negative y would be negative 2y. And if I multiply negative 5 by 2, I get negative 10. And then the second equation, I'm not going to change it at all. I just have x plus 2y equals 4. So now, as you can see, when I add these two equations together, I get 3x plus 0y equals negative 10 plus 4 is negative 6. And of course, the y's go away, and I can solve this equation for 6, or for x rather. So right now, I'd like you to stop this recording and copy down these two examples, just like you see them here on the screen. So pause the recording and copy these down now, please. Okay, here's another system of equations where there are no opposite terms to add up. But I'd like you to look at this and think about what could you multiply that first equation by to get an opposite term. So I'd like you to, one more time, pause this recording and write down this system of equations and think about what could I multiply that first equation by in order to get an opposite term. So think about that for a while, and when you've made up your mind what you're going to multiply the equation by, then start the video again and we'll talk. Okay, now that you've thought about it, one thing that we could have done here is to multiply that first equation by negative 2. And so the first equation then would become negative 2x minus 6y equals negative 6. So that's what we get if we multiply the first equation by negative 2. That second equation, we would just write the way that we wouldn't change it at all, because that wouldn't help us. So now you could add up these two equations and the y's will cancel out. You can see that you have your opposite terms here, and these would cancel out. Now you might have been thinking that you could have also multiplied that first equation by -1 and canceled out the x terms, and that's true, you could have. So let's multiply the first equation by -1. That would give me -x minus 3y equals -3. And if I just use the next equation unchanged, I get positive x plus 6y equals 3. And if I go to add these up, then -x and positive x will cancel each other out. And so either way, you could have solved this equation by either multiplying, or the system, by multiplying the first equation by -2, or multiplying the first equation by -1.